different rules and semantics. A lot has been written about C++ references, and there are many opinions about whether they're necessary or useful or good or bad, but this much is true. They're here to stay, and you'll need to understand them in order to use them. So let's make a working copy of references.cpp. We'll paste that into our working project and double-click on it to open it in the editor. And let's take a quick look at this example. Here on line 6, we're declaring and initializing a variable I. It's an integer. And we're giving it a value of 5. And then on the next line, we're declaring a reference variable. This is of the C++ reference type, and we're calling it IR, and we're initializing that reference to I. So now IR is a reference to I. So when we set IR and give it a value of 10, and then we're going to print out the value of I. Now remember, we set I to 5, and our reference got changed to 10, so when we run this, we'll see that I is now 10. And you notice this syntax. I don't have to dereference it. I don't have to put an asterisk or anything in front of it. I just say IR equals 10, and it actually changes the value of I. So reference works very much like a pointer, but with some significant differences. The syntax of setting a reference is different and does not involve using the address of operator. So in other words, here on line 7, I don't have to do this. As I would with a pointer, I would have to set it like that to the address of I. Here I'm just setting the reference to equal I. The syntax of getting the value referred to by a reference also does not involve the dereference operator. So when I want to set or take the value of it, I don't have to put an asterisk in front of it like that to dereference it, because it's not a pointer, it's a reference. The whole idea of references is to make them more transparent, and in some ways to make them safer, and in other ways it obviously also makes them more dangerous. You cannot refer to the reference itself. That is, you cannot take a reference of a reference, you can't have a pointer to a reference, and you cannot have an array of references. And a reference cannot be null, it cannot be uninitialized, and it cannot be changed to refer to another variable. So in other words, if I were to say IR equals J, where J is some other variable, it's really just going to copy the value of J into I. It's not going to change the reference variable itself. There's no way to change a reference variable once it's been set. Now, a really common usage of this, and this is actually where you're going to see these things the most commonly, is in functions and methods. So here I'm going to declare a function. I'm going to say it's int reference. So it returns a reference to an int, and we'll just call the function f, and it takes a reference to an int as its argument. And I'm just going to return the increment of that int. So all it'll do is it'll take that integer reference and it'll increment it and it'll return a reference to the integer. So I'm going to get rid of these things here and I'm just going to say f and pass it I. Now you'll notice the way that I called it, I'm just passing it I like I would any other function. And if the function was not taking a reference, then the function would make a copy of I and it would put it on its stack and it would create an automatic variable internally and it would increment that and return that value. But instead, it's going to do something very different here. Notice we're printing out the value of I, and when I compile this and run it, you see that I is now 6. What the function has done, it has actually incremented I. It's affected something outside of its own scope. And it's done that because we're no longer calling by value now. Now we're calling by reference, and we're actually able to affect the things outside of the function. This gets even more insidious, if I can use that word, when I do something like this. I'm now assigning a value to what's being returned by that function. And remember, what's being returned by that function is a reference to I. So what happens here is that I is now 42. And this is commonly how things like operator overloads are done, and we'll cover that when we get to C++ classes later on in this course. But for now, you need to know that this is something that can actually be very dangerous. The intent with references was to make some things easier and to make some things safer, but it also made some things more dangerous. So here's a solution. Every time you use references in a function, you return references or you pass references, you always want to declare them as const unless there's a good reason not to. And there will be times when there's a good reason not to. So if I say const int for the return type and const int for the passing type, notice what happens here. I'm going to save this and I'm going to compile it. And we're going to get a couple of errors here. First of all, inside of the function, I'm no longer allowed to increment because that's a constant value now. So it's not letting the function actually impact the variable that was passed to it. And likewise, on the return value, I'm not allowed to assign to it because I'm returning a const int. So in my opinion, references should have defaulted this way. But it's okay, we have the qualifier const, and if we just get into the habit of using it all the time, except where we actually intend to have these side effects, then our code is going to be a lot better and it's going to be a lot safer. If you actually want to have side effects, my recommendation is to use pointers where you can instead of references. And obviously, there are a lot of people who disagree with my opinion on that. You need to be aware that there's a lot of code out there that uses non-const references, including quite a bit of the standard template library. So you just need to be conscious of this effect. References are very powerful and very common in C++. We'll be using references quite a bit, and you will gain much more experience with them in the rest of this course. Now let's